So in problem number 1, we're asked to find, using analytic methods, the global extreme values. Now the global extreme values is just a funny way of saying the absolute max and the absolute min. This problem is given on a closed interval, so we use something called the closed interval method. We're going to find the values of this function wherever there's a critical value, meaning the derivative is 0 or undefined, and also at the endpoints. Whichever functional value is highest has got to be the absolute maximum on that interval. That whatever functional value is lowest has got to be the absolute minimum. All right, so let's start by looking at its derivative. Y prime, we've got a product rule here. First times the derivative of the second. Chain rule plus the second times the derivative of the first. See if I can clean that up a little bit. I get a negative x on top, and I have 2 times the square root of x, 2 minus x plus root 2 minus x on top for that second term. Would you please check to see if I made any calculus or algebraic mistakes? Okay. Now we want to set this equal to 0, and we want to find when it's equal to 0. The trick to this particular problem is common denominator, and then only checking out when the numerator is equal to 0. The common denominator is right here. So I'm going to take this, and I'm going to multiply it by 2 root 2 minus x, both top and bottom. And I get negative x plus 2 times the quantity, 2 minus x, because the 2 roots cancel out on the top. And then on the bottom, I have 2 root 2 minus x. We're going to recognize, by the way, that when x is 2, the denominator is 0. That would also be a critical point, but it also ends up being an endpoint. So I'm not too worried about that. Let's try to figure out when the top is equal to 0. When is negative x plus 2 times the quantity 2 minus x equal to 0? That's negative x plus 4 minus 2x is equal to 0. That looks like 4 is equal to 3x, or x is equal to 4/3. Is 4/3 in our interval? Okay, so here's my end game. I want to find out what is the value of y when x is negative 2, one of the endpoints. So it's negative 2 times 2 minus a minus 2, or negative 2 times the square root of 4. It looks like it's negative 4. So there's my one endpoint. Let's find out what is the value of y when x is 4/3. That's 4/3 times 2 minus 4/3. The square root of 2 minus 4/3. That's 4/3 times the, what's that going to be?
2/3.
2/3?
Yeah. I don't understand why you're finding 4 times 1/3 of 6/3.
Because the maximums and minimums are going to occur either at the endpoints or at the places where the derivative is equal to 0. By setting that equal to 0, I found out that the numerator of the derivative is 0 when x is 4/3. So that's a
4/3 is also one of your answers, right? Is 4/3 also one of your answers? I mean, it is one of the answers, but do you get it from there, or do you get it from
well, my answers are going to finding the global extreme values. The extreme values are going to be y values. So 4/3 is the location of a possible global extreme. So can I get an approximation for what that is?
They have it as 4 times the square root of
I suppose 4 root 2 over 3 root 3. And if you rationalize that, you end up with 4 root 6 over 9. Okay. And then the last possible place where there could be a global extreme value, and that's when x is equal to 2, and that's 2 times 2 minus 2, and that's equal to 0. Well, let's just say I recognize this as my absolute minimum. It's the only negative value amongst those three. I recognize this as my absolute maximum. It's the only positive value amongst the three. Is that complete?
Yeah.
All right. What's that?
No, they're saying the location.
Okay, here's what they say. They say maximum 4 root 6 over 9 at x equals 2/3. X equals 4/3. Maximum is this, and you would find it at 4/3. Then they say minimum is -4 at x equal -2. So whenever they use the word maximum or minimum, they describe the y value, not the x value. All right, so that's problem number 1.